Okay, hello. Good morning to you, Jia En. Okay, this is a recording for 1st November session. Okay, so okay, today we will look at how to solve trigonometric equation as well as to prove trigonometric equation, because okay, actually I took out 2025 O-level A math question, okay, to discuss over here. Okay, and I think in the O-level A math question this year, okay, proving and solving trigonometric equation is actually together lah. Okay, but our tutorial we will only focus on solving trigonometric equation. Okay, proving trigonometric equation, okay, will be the next exercise lah, which is exercise 4. Okay, so I will start with the tutorial question first, then after that we will discuss the this year's O-level A math question. Okay, actually there's two question. Okay, later I'll show you, okay, the paper. Okay, so for the tutorial, okay, I will discuss 4 questions. Okay, we will start with question 5 first. Okay, so for question 5, okay, we have the following expression: 7 tangent x plus 2 divided by 3 minus tangent equals to 4. Okay, for x is bigger than or equal to 0 degree, less than or equal to 360 degree. So this bound here, okay, is very important, because later, okay, this will tell you that your answer, okay, your final answer, okay, need to satisfy this range. Okay, and okay, the first thing is, okay, whenever you have a trigonometric equation, okay, you need to ask yourself a few questions. Okay, do I need to simplify the given expression using some form of trigonometric identity? For instance, compound angle identity, double angle identity, or Pythagorean identity. Okay, that's the first thing you ask yourself. Okay, if not, okay, can I factorize any common term that I see down here? Okay, or okay, if it's a rational function on one side, okay, can I remove the denominator in the rational function on both sides? Okay, these are the few questions that you should ask yourself. Okay, and in this case, at one look at this expression, okay, I do not need to use any form of identity. Okay, because here I only have tangent x. It's not like I have tangent bracket x plus y, or tangent 2x, correct? Or cosine 2x, or sine 2x, that kind of thing. So I don't need to use any form of identity. Okay, in this case, my left hand side is a rational function. Okay, rational means fraction. Okay, so okay, a common approach, okay, that you think of is to multiply both sides by the denominator. In this case, multiplying both sides by 3 minus tangent x. Okay, then your left hand side will be 7 tangent x plus 2. Okay, then 3 minus tangent x you multiply by on both sides. So my left hand side will not have 3 minus tangent x. Okay, because it's being multiplied to the right hand side. Okay, then I have a 4 outside, right? So if I expand the 4 in, I have 4 times 3, 12. 4 times minus tangent x minus 4 tangent x. Okay, and then the next step will be, okay, to move all the tangent x to one side, all the constant to one side. So the minus 4 tangent x I can move the other side, which is by adding 4 tangent x on both sides. So on my left hand side I have 11 tangent x. Okay, and then the 2, positive 2, I can move to the other side by subtracting 2 on both sides. So I have, okay, 2 minus 2, 0. 12 minus 2, 10. So I will get 11 tangent x equal to 10. Okay, and then the last step is to make it become tangent x instead of 11 tangent x by dividing both sides by 11. Okay, then I get down to the final expression. Okay, now, okay, take note, this is our final expression, right? Correct? From the given one. Okay, so from here, okay, it is clear that tangent x is a positive value, which means your underlying angle x, okay, according to ASTC rule, it should lie in Q1 and Q3. Okay, so later your answer for x, you have to find in quadrant 1 and quadrant 3. Okay, using the ASTC rule, for quadrant 1, x is equals to your reference angle. Quadrant 2, x is equals to 180 minus your reference angle. Quadrant 3, x is equals to 180 plus reference angle. And quadrant 4, x is equals to 360 degrees minus reference angle. Okay, this is the ASTC rule, which, okay, you have been taught in school. Okay, okay, but before you find that, we need to find our reference angle or basic angle, denoted by alpha. Okay, so you move tangent to the other side is equivalent to taking up tangent or inverse tangent. Okay, and take note, in this case, 10 over 11 is a positive. What happens if this is minus 10 over 11? Then when you find the reference angle, okay, we will drop the negative sign, okay, and we take the positive sign instead. Okay, because your ASTC rule, okay, you move in the counterclockwise direction and the sign is positive. Okay, later you see, I think the next question, this value here is a negative value. Okay, later you'll see in the next slide. Okay, but for now, just take note, just remember, if this 10 over 11 is the minus, is a negative value, okay, then when you find your alpha, okay, you should not take the negative sign. Okay, you should not consider negative sign. Okay, you drop the negative sign, okay, and then you just take inverse tangent 10 over 11. Then press calculator. In degrees mode, I should get 42.27 degrees. Okay, then just now I mentioned, right, tangent x is a positive value, right? In fact, positive 10 over 11. So my x should lie in Q1 and Q3. Okay, so this statement here. Okay, yeah, and you notice here I use some shorthand notation for set theory. Okay, basically x, okay, this E means element. X is an element of Q1, x is an element of Q3, meaning x belong to Q1 or x lie in Q1 and x belong to Q3 or x lie in Q3. Okay, if you don't like to use this kind of notation, which is introduced in the topic of sets or set theory, okay, it's actually under E-math lah. Okay, I think, okay, you should have learned this already in Sec 3. If not, you will definitely learn in Sec 4. Okay, set theory or sets. Okay, you can just write in English. Okay, you can say that this imply x lie in quadrant 1 and x lie in quadrant 3 in English statement. Okay, you can just write in English if you don't want to use mathematical sets notation. Okay, then, okay, the last step is to find out Q1, okay, which is x equals to your reference angle, 42.27. Q3, x equals to 180 plus your reference angle, okay, which is 222.3. Okay, and the last thing, okay, which I've, okay, told the other girl, I think Shermin, okay, is, okay, you can take this answer, you substitute back into the original expression, and then you see whether do you get approximately 4. If you get approximately 4, then these two answer is validated as correct. Okay, because look at the question asks you to solve this particular trigonometry equation. It's like E-math, right, asks you to solve quadratic equation, right? And usually you will get two roots, correct, two solutions, and usually the solution, if you substitute back into the original expression, you should obtain equality. So the same thing for trigonometric. Okay, you can verify your answer easily by plugging back the final answer into the expression, into the trigonometric expression, and then you see whether do you get 4 or approximately 4, like 3.99 something, okay, or 3, yeah, okay, which is close to 4. Okay, okay, in this case I will not get exactly 4 because my answer is a decimal place, rounded up to 1 decimal places, so I should not expect exactly 4. In fact, I should get 3.99 something, close to 4. Okay, which is correct. Okay, and your answers, okay, just like I said at the start, right, it must satisfy this inequality here. Clear enough, 42.3 degrees is bigger than 0 and less than 360 degree. Okay, similarly, 222.3 degree is bigger than 0, less than 360 degree. So the two answers are 42.3 degree and x equals to 222.3 degree. These are the answer that satisfy this trigo equation. Okay, so step 1, simplify the expression, okay, by using some general mathematics rule, okay, like for example multiplying both sides by the denominator, okay, and then move all the terms with tangent x to one side, all the numbers to one side. Okay, basically your general rules in mathematics lah. Okay, okay, those things that you do, those usual things that you do in E-math. Okay, okay, but of course if you need to use any identity beforehand, that one you have to do first. Okay, later I think in the O-level A-math question, this year's one, okay, you will see, okay, the expression is not so direct. Okay, you need to do some form of manipulation using some form of identity before you can even further simplify the expression. Okay, for the tutorial question, it's quite straightforward. Okay, for question 5. Next, question 12. So you see this expression, find sin x cosine x plus 4 cosine x equals 0. Okay, where x is given in this range, 0 degree to 360 degree inclusive. So you ask yourself, again, this expression here, okay, do I need to do any manipulation, like do I need to use any identity? Okay, like compound angle, double angle, degree identity. Okay, the answer is no. Okay, because here is very simple. Okay, we are dealing with sine and cosine x only. Okay, there is no sine square x, there is no cosine square x, there is no cosine 2x, there is no sine 2x. Okay, so it's quite straightforward. Okay, so we don't need to use any form of identity. In fact, okay, if you relate to your EMF, you think of the word that start with F. What is that? F stand for factorize. Factorize, because we can see that cosine x is common. Okay, so if we pull out cosine x, we have 5 sine x plus 4. Okay, equal to 0. This one. Okay, and okay, based on what you do in EMF, if the product of two terms equal to 0, this implies that the first term equal to 0 or the second term equal to 0. Okay, clear? Okay, however, for the second term, we need to simplify a bit. Okay, we need to make it sine x on the left hand side, but down here we have 5 sine x plus 4, so you have to do a bit of simple simplification. Okay, by subtracting 4 on both sides and then dividing 5 on both sides, then we will get down to sine x equals to minus 4/5. Okay, note that just now okay, question 5 okay, my tangent x is positive, right? Correct. But now what happened to question 12? My sine x is negative. Okay, so which means later when you find the reference angle for sine x equals to minus 4/5, okay, we will take inverse sine positive 4/5, not inverse sine minus 4/5. Okay, so take note. Okay, now for cosine equals 0, your reference angle will be inverse cosine 0, which is 90 degree. Okay, for sine x to minus 4/5, your reference angle will be inverse sine 4/5. This is what I say. Okay, when you find the reference angle, you drop the negative sign. Okay, take the positive value instead. Okay, then you press calculator, you get 53.13 degree. So these are your reference angle. Okay, think of reference angle like a fixed point. Okay, like a fixed point. Okay, for you to find the underlying angle in the underlying quadrant. Okay, so for cosine equals 0, note that this cosine x is positive. So this implies that x lie in Q1 and Q4 based on your ASDC rule. Okay, then you go and find the underlying quadrant. For Q1, x is equals to your reference angle alpha, which is 90 degree. For Q4, x is equals to 360 minus alpha. Okay, alpha here is 90 degree. So you subtract from 360 degree, I get 270 degree. Okay, and these two answers, okay, are for cosine x equals to 0. Okay, now for sine x to the minus 4/5, notice that sine x is negative. Okay, and ask yourself, in the event of sine x equals to positive, which two quadrant x lie in? Q1 and Q2, correct? Correct, that is for positive scenario. For negative scenario, it will be the other two quadrant, which is Q3 and Q4. Okay, so sine x is negative, so x will lie in Q3 and Q4. Then you go and find the actual angle in the underlying quadrant. For Q3, it will be 180 plus alpha. Here my alpha is 53.13. Okay, then you evaluate, you get 233.1 degree. For Q4, 360 degree minus alpha, which is 53.13 degree. Okay, then you get 306.9 degree. Okay, so the final answer are the one in bold. Okay, same thing, you can do a sanity check. Okay, like what I told Shermin. Okay, you plug 90 degree, 270 degree, 233.1 degree, and 306.9 degree into the original expression. So for example, 5 sine 90 cosine 90 plus 4 cosine 90. That should give me 0 if you plug into the calculator. The same thing for 270, 233.1 degrees, and 306.9 degrees. Okay? Okay, so yeah, you can verify your answers easily. Just like quadratic equation. Once you have solved the quadratic equation, normally you get two roots. Then what you do, you take the two roots, you substitute back into the expression. Make sure you get equality. Okay? Yeah, once you get equality, which means your answer is correct, which means the marker cannot mark you wrong. The marker should award you full credit or full mark. Okay, the same thing for simultaneous equation. Okay, usually it's 3 mark, and usually your answer can be verified easily. Just sub it back to the original expression. Okay, so it's the same thing for trigo. Okay, and notice that the keyword here is what? Solve. Correct? Solve. Okay, whatever is on the left hand side equal to 0, which means the value that you get for x when you substitute back into the trigo function, okay, I should get 0. Okay, the same for quadratic equation, okay, or simultaneous equation. Okay, so yeah, okay, you can verify answers easily. And the last thing to do is to check these 4 answers in bold. Do they satisfy the given range here? Okay, the answer is yes. Okay, if any point of time the answer don't satisfy the range, then you have to reject. Okay, you don't take the answer. Happily, you don't take the answer. If let's say one of the answer you get 380 degree, then the 380 cannot, you have to reject. So, okay, in this case, your answer will be only three acceptable answer. Okay, due to the range given here. So take note. Okay, 2 things. Once you have, okay, follow the process. Okay, so the process, let me repeat again. Okay, step 1, simplify the expression. Okay, try and look at the expression. Ask yourself whether do you need to use any form of trigonometric identity. If no identity is required, what kind of rules you need to do to simplify the expression? Okay, be it whether factorize out common term, or multiply both sides by the denominator if it's a rational function. Okay, things like that. Okay, so once you have do that, then find your reference angle. Okay, then deduce which underlying quadrant the actual angle lies in, and then go and find the actual angle. Okay, and once you finish the whole thing, okay, don't forget to substitute back your original expression. Make sure you get 0 on the right hand side. What happens if you have cosecant, secant, cotangent? Because your calculator got no cosecant, cotangent, and secant, right? Right? What you do is, okay, recall cosecant is the reciprocal of sine, cotangent is the reciprocal of tangent, and secant is the reciprocal of cosine. So you can write in terms of that, and then substitute back the answer. Okay, then make sure you get whatever that is on the right hand side. Okay, this is how you check the answer. Okay, in the event of an examination. Okay, if you want to assure that you score full marks for question 12, exercise 3, this is what you do. Okay, question 16. So question 16, find all the value of x satisfying this expression here. Okay, for x given in the range 0 degree to 360 degree, exclusive, which means the endpoint is not included. Okay, so what's your approach? Okay, you may think that, okay, this looks very similar, right, to the compound angle identity, correct? Sine bracket a minus b, correct? And then you expand, you get sine a sine b minus cos a cos b. Okay, you may want to do that, but if you do that, okay, you may still get the final answer in the end, but okay, it's a long process lah. Okay, in fact, a clever way is to use appropriate substitution. So in fact, I can let y equals to x over 2 minus 10 degree. Okay, and note that when you use an appropriate substitution, okay, the bound given here, your range, okay, will no longer be 0 degrees and 360 degree on the lower and upper bound. It will change, okay, because this inequality is defined for x. But when I use, let's say I use y equals to, I let y equals to x over 2 minus 10 degree, then my lower bound will be negative 10 degree. How I get negative 10? 0 degree divide 2 and then minus 10 degree. Okay, that is minus 10 degree. And then your upper bound will be 170 degree. How I get 170? 360 degree divide 2, which is 180 degree. Okay, and 180 degree minus 10 degree, that is 170 degree. Okay, so this is what I say lah. Okay, let y equals to whatever that is inside this parenthesis. Okay, so your expression will be sine y equals to 0.71. And then, okay, this y is defined for between minus 10 to 170, which means when you work out your answer in terms of y, okay, it should fall in between minus 10 degree to 170 degree. Okay, it should not fall 0 to 360, because 0 to 360 is for x, defined for x. Okay, can? Okay, and the next step is, you see, my expression, sine y equals to 0.71. Okay, this is already the simplified, correct? So the next step I can do is I can find alpha, my reference angle or basic angle, okay, by taking inverse sine 0.71. Okay, so you do that, you get 45.23 degrees. Okay, and then sine y is a positive value because 0.71 is a positive value, correct? Okay, and this tells you that y should lie in quadrant 1 and quadrant 2, okay, according to your ASTC rule. Okay, then you go and find, okay, what is the actual angle y in Q1 and Q2. For Q1 it will be 45.23. Okay, for Q2 it will be 180 degrees minus 45.23 degrees. Okay, which is 134.77 degrees. Okay, now you may ask yourself, is this the final answer? No, because the answer is given to you. In fact, the equation given to you is in x. Okay, y is our substitution. Okay, see the one in red color. Okay, y is our substitution. Okay, so okay, these two answers are not the final answer. You have to substitute back in. So 45.23 equals to x over 2 minus 10 degree. Similarly, for this 134.77 degree equals to x over 2 minus 10 degree. Okay, and then this is your simplification. Okay, how you simplify. Okay, for this part, okay, I just plus 10 on both sides and then times 2. Okay, I get x equals to 110.5 degree. Okay, and then for this part, okay, I add 10 degrees to 134.77, followed by I multiply by 2. I get x equals to 289.5 degree. And you check, okay, so okay, sorry, for y, just like I mentioned, right? Okay, for y, you get 45.23 and 134.77, right? Okay, you should check that these two answers strictly fall in this range. Okay, if let's say for some reason, why you get 200 degrees, then you know that is not the answer, because your upper bound is 170. Correct? 200 degrees is outside of this range. Okay, clear? Which means you have to double check now. Okay, the part that you get y equals to 200 degree. Okay, in this case, these two answers for y fall in between the range here, so it's okay. Okay, then I can go and find my x. Clear? And same thing, when you get down your x, the answer for x, okay, which is 110.5 and 289.5 degree, make sure it fall within 0 to 360 degrees. Okay, okay, and the last thing you want to do is you can substitute back into the given expression. Sine bracket 110.5 divide 2 minus 10 degree, close the bracket, and then press the equal sign. I should get about 0.71. The same thing for 289.5 degree. I substitute back here, I should get approximately 0.71. Okay, that is what I call sanity check, how the student can verify the answer in the event of exam. Okay, if you are not sure whether your answer is correct, okay, whether these two answers is correct, okay, what you can do is you substitute back into the expression, make sure you get 0.71, close to 0.71. Okay, in this case, I will not get exactly 0.7 because my answer is rounded up. Okay, if I get integer, okay, if let's say x equals to 4, or rather not 4, x equals to 20 or x equals to 100, then for sure when you substitute back here, I will get exactly 0.71. Okay, but because in this case my answer is rounded up to 1 decimal places, okay, for this and this, so I will not get exactly 0.71, but close, like 0.70 something, okay, or 0.7 something, okay, close. Okay, so this is what I call sanity check. Okay, okay, and make sure your answer, okay, fall between the range as defined in the question. Okay, this is very important. Okay, last question, okay, for the tutorial before we talk about this year 2025 A math question. Okay, so for this one, okay, this question is similar to the previous question, question 16. Okay, where I will use appropriate substitution. Okay, here you may think that you want to use compound angle, right? Okay, tangent bracket A plus B, that one, but actually no need, okay, I can just use substitution, because if you use that compound angle identity, okay, I think you will go through a longer process. Furthermore, okay, if you're not sure how to simplify using compound angle identity for tangent function, okay, you are like, okay, the student will be likely to make mistake. Okay, so I don't suggest, okay, that approach. In fact, use substitution. Okay, same thing. X is defined for 0 to 2 pi. X bigger than 0, less than 2 pi. So for x is defined in this range. So if I use, let's say, an appropriate substitution, let's say I let y equals to 2x plus pi over 3, then, okay, the range will change. Okay, it will not be 0 and 2 pi on the lower and upper bound respectively. So if I let y equals to 2x plus pi over 3, then my lower bound will be what? 0 times 2 minus pi over 3, which is negative pi over 3. Okay, and my upper bound will be 2 pi times 2, which is 4 pi, plus pi over 3, which is 13 pi over 3. Okay, here, this part. Okay, can you see? My laser is pointing at the part here. Okay, so if I let y equals to 2x plus pi over 3, I use appropriate substitution, then tangent y equals to minus 1 will be defined for this range. It cannot be 0 to 2 pi. Okay, it will be between 60 degree or pi over 3, okay, to 13 pi over 3 or 7 80 degree. Okay, so this is the range, which means when you work out your answer for y, your answer should strictly lie between pi over 3 to 13 pi over 3. Okay, or equivalently in degree, between 60 degree to 780 degree. If you get, let's say, 50 degree or worse, minus 40 for one of the answer in y, then something wrong. Okay, because here I already work out my inequality. My y should lie strictly between 60 degree to 780 degree, or pi over 3 to 13 pi over 3. So when you work out your answer for y, okay, it should lie between this range. Okay, between pi over 3 to 13 pi over 3. It cannot lie outside of the range. Okay, so looking back at our expression, tangent y equals to minus 1, right? So the next step you may want to think is reference angle. Okay, and notice tangent y is negative. So when you find reference angle, drop the negative sign. So it will be inverse tangent 1. And this is actually your special angle, which is pi over 4. Okay? Okay, or 45 degree. Okay, see? Okay, when you find your reference angle or basic angle denoted by alpha, okay, you drop the negative sign. So it will be inverse tangent 1, which is pi over 4. Okay? Okay, like I say, okay, if this is negative, okay, when you find reference angle, do not factor in the negative sign. Okay, because the given inequality, okay, is in counterclockwise direction, which means the sign is positive. That's why when you find the reference angle, okay, the negative sign is not considered. Okay, you drop the negative sign. Okay, so your reference angle is pi over 4. Okay, note that we have to leave answer in radian, not degree. Okay, here I put degree here as well as this part and this part is to show you, okay, what is the equivalent angle, okay, in degree for 13 pi over 3 and pi over 3 and pi over 4. Okay, but okay, your answer when you work out have to be in radian. Don't forget, because the given question defined for you is in radian, not degree. So make sure you don't leave your answer in degree. And clearly radian is less than degree. Degree is always larger than radian. Okay, so make sure everything must be in radian. If you want to work in degree, if you feel comfortable working in degree, fine, you can do that. But don't forget to multiply everything by 180 over pi. Okay, to convert back to radian. Clear? Okay, so once you have the reference angle, okay, look back at this expression, tangent y equals to minus 1. This tells you that tangent y is negative, right? So according to ASTC rule, y should lie in what? When tangent y is positive, it lie in Q1 and Q3, right? When tangent y is positive, it lie in Q1 and Q3. When tangent y is negative, it lie in quadrant 2 and quadrant 4. Okay, here, can you see? Okay, since tangent y equals to negative 1 is negative, so this tells you that y should lie in Q2 and y should lie in Q4. Okay, then you're going to find the underlying angle y in Q2, which is sorry, not 180, pi. Okay, pi, because now we are dealing with radian. Okay, so pi minus pi over 4. Okay, your alpha for Q2. For Q4, 2 pi minus pi over 4. Okay, so okay, you realize this additional step here, okay, why I add 2 pi, correct? Okay, I'll come to that shortly. Okay, so what I said previously is for Q2, pi minus reference angle, correct? And our reference angle is pi over 4, which is 3 pi over 4, or equivalent in degree, 135 degrees. Okay, if you multiply by 180 over pi. Okay, so 135 degree and 3 pi over 4 are the equivalent value. Okay, the same thing for Q4, right? 2 pi minus your reference angle, I get 7 pi over 4, or 315 degree. Am I right? Then you notice why I add another 2 pi, correct? Both for quadrant 2 and quadrant 4, correct? You see this part, okay, the one in bracket, pi minus pi over 4 is essentially this part, right? Correct? And 2 pi minus pi over 4 is essentially this part, correct? Correct? Why I need to add an additional 2 pi? Basically, one extra revolution. Why do I need to do that? Because if you look at your substitution, okay, or rather the given expression, correct? 2x plus pi over 3, correct? There is an additional of 2x, right? And correct, which means, okay, I need to go one more revolution, which means 2 pi. 2 pi is 360, correct? So which means I have to go one more revolution, correct? Okay, I have to rotate one more time, okay, because there's an additional of 2 pi, correct? Therefore, okay, the final answer for y in Q2 and Q4 is I have to take 3 pi over 4 plus 2 pi, which gives me 11 pi over 4. And for Q4, I have to take 7 pi over 4 plus one more revolution, which is 2 pi, because one revolution is 360 or equivalent in radian 2 pi. So I have to go one more time. Okay, that's why I plus 2 pi. So 7 pi over 4 plus 2 pi, I get 15 pi over 4. Okay, and don't forget to verify answer for y. Like I say, it should lie between 60 to 780 degree. And clear enough, for 495 is bigger than 60 but less than 780. Okay, similarly 675 degree is bigger than 60 degree but less than 780 degree. So these two answers are okay. Okay meaning they are well defined based on your range for y here. Okay, but is 495 degree and 675 degree the answer? No, because your answer is in x. Okay, they asked you to solve in terms of x. Okay, so we need to substitute back in. Okay, so in fact, okay, there are 4 answers here. 3 pi over 4, 7 pi over 4, 11 pi over 4, 15 pi over 4. Okay, for 11 pi over 4 and 15 pi over 4, 15 pi over 4, okay, we have to add one revolution. Okay, on top of the original answer. Okay, on top of 3 pi over 4 and 7 pi over 4, we have to add one more time, one more revolution. Okay, so your answer actually there are 4 answers: 3 pi over 4, 7 pi over 4, 11 pi over 4, and 15 pi over 4. Okay, but these are for y, not x. So the final answer is, okay, you have to substitute back each of the 4 answers here into your substitution. So 3 pi over 4 equals to 2x plus pi over 3. 7 pi over 4 equals to 2x plus pi over 3. Okay, then 11 pi over 4 equals to 2x plus pi over 3. 15 pi over 4 equals to 2x plus pi over 3. Then you solve for x. Okay, like that. Okay. Okay. This is for the first answer, right? 3 pi over 4. Okay, then you solve for x, you get 5 pi over 24. Okay, I will say when you try and solve for x, try not to make silly mistake. Okay, or try to make silly mistake. Okay, in fact, the first step, okay, you should subtract pi over 3 on both sides first. So 3 pi over 4 minus pi over 3, and then divide by 2. Answer divide by 2. 3 pi over 4 minus pi over 3, then you press the equal sign, then divide by 2. Then I should get 5 pi over 24. Okay, similarly the other 3 Okay, I don't want to explain. It's the same thing. Okay, yeah. Okay, then my final answer will be 5 pi over 24, 17 pi over 24, 29 pi over 24, and lastly 41 pi over 24. These are my answers. Okay, similarly in radian mode, okay, I can substitute back into the original expression. Your calculator got tangent function, right? Correct. So what you do is you press the tangent function followed by open bracket 2 times 5 pi over 24 plus pi over 3, close the bracket. I should get close to minus 1. Okay, the same thing for the other 3 values: 17 pi over 24, 29 pi over 24, 41 pi over 24. Okay, that is one quick verification. Then one last thing is make sure your this 4 value of x is well defined for this range of inequality here, meaning it should be bigger than 0, less than 2 pi. 2 pi is about 6.283. Okay, in decimal, if you press calculator, 2 pi is about 6.283. Okay, so yeah, it should satisfy this range. Okay, so okay, for the tutorial, I've come to the end of it. Now we will discuss about the O-level A-math question. So I will just quickly wait. Okay, it's still recording. Okay, need to check. Suddenly later my recorder stop recording. Okay, so okay, the last thing is, okay, as what I promised you earlier, okay, we will discuss this year's 2025 O-level A-math question. Actually, the paper is passed this week. Okay, I can't remember, is it Monday or Wednesday, paper 1 and paper 2 respectively. But okay, the A-math paper, okay, it was just over a few days ago. Okay, and this is the paper okay, taken by your seniors in set 4. So you can see at October, November 2025. Okay, so it's a real paper. Okay, not play one. It's a real paper. Okay, so yeah. So okay, the trigonometry question for paper 1 is question 9. Okay, where part A asks you to prove first. Correct? Prove the left hand side equals to right hand side, and then part B, solve. Okay, and they give the range. Theta is between 180, which is pi, and 270, which is 3 pi over 2 in radian. Okay, so like that, 7 mark, right? 4 mark plus 3 mark, 7 mark. So this is okay. The trigonometric question tested in paper 1. First part asks you to prove, second part solve. Okay, and solve trigo equation is what we are doing today. Okay. Okay, is our focus. Okay, proving will be the following week after. Okay, will be after solving trigo equation. Okay, for paper 2, okay, we have one more trigonometric question. Okay, this one, if I'm not wrong, is a pure solving question. Question 6. Okay, it's worth 7 marks. Yeah. Okay, question 6, you see, this question is standalone, meaning there's no part, part A, part B, standalone question. Okay, and then just give to you 7 mark like that. Ask you to solve this equation. Okay, and again they give you the range. Okay, and take note what I said in the tutorial just now. Whenever the question give you the range, your answer for theta have to sit between 0 degree to 360 degree, inclusive of the endpoint. Okay. Okay, and when you substitute your answer for theta, the final answer for theta, okay, you have to get 0. And take note, this is cosecant and cotangent. Okay, which means your calculator don't have cosecant function and cotangent function. So what you do is, okay, when you want to validate your final answer for theta, what you can do is, okay, we know that cosecant is a reciprocal of sine, right? Correct? So cosecant square theta will be 1 over sine square theta. So you may want to write that first. 2 times 1 over sine square theta. Okay, then you move the 2 in, you have 2 over sine square theta. Minus cotangent is what? The reciprocal of tangent, right? So you may want to write 1 over tangent theta. Then minus 3 equal to 0. Okay, so I repeat again. Okay, when you want to validate answer, you may want to, okay, write this equation in another equivalent form, which is 2 over sine squared theta minus 1 over tangent theta minus 3 equal to 0. Then you substitute your answer for theta, and then you see whether you get 0. If you get 0, means congratulations, your answer for theta is correct. Okay, and you have to verify all. If let's say theta, there is, let's say for example, 4 choices of theta, you have to validate all 4. Okay, make sure you get 0 on the right hand side. Okay, if let's say your final answer for theta, you have 3 answers, you have to validate all 3 of them. Okay, make sure it satisfy the equation. Satisfy meaning you get 0 on the right hand side. Okay, define for this range. Okay, then 7 mark is yours. Okay, so the paper is out of 90 mark. So if you can get 7 mark secure, okay, if let's say you are aiming for, let's say example C6, just pass. Okay, how many more mark you need? Okay, paper 1 and 2 are equal weightage, okay, which is 90 mark each. So this is paper 2. So if let's say question 6, you get full mark. Okay, and then you are aiming for just pass, right, which is 45. Okay, because 90 mark, the passing mark is 45. You need another 38 marks. Correct? Okay, to get from other question. Okay, but I will say this question on solving trigonometric equation that is worth 7 marks is not difficult. Okay, you just need to know, okay, what is the approach to take. Okay, usually for solving equation, okay, like what I mentioned in the tutorial, first step is to simplify the expression. How you simplify? Either we call the general rules, okay, in mathematics. Okay, for example, if it's a rational function, you may want to get rid of the denominator by multiplying both sides by the denominator. Okay, or if you have common term, you may want to factorize out the common term. Okay, the keyword F stand for factorize. Okay, or okay, you may want to use some form of trigonometric identity, okay, to transform the equation first. Okay, I will call that manipulation. Okay, before even you find the usual things like reference angle, deduce which quadrant the underlying angle lies in, and then proceed to find the underlying angle in the respective quadrant. Okay, so before even you do these 3 things, okay, reference angle, deduce which underlying quadrant the angle lie in, and find the angle, okay, that lie in the respective angle quadrant. Okay, you need to do some simple manipulation. Okay, be it whether it's using trigonometric identity or your usual rules, okay, of mathematics. Okay, so okay, these are the 2 questions okay, that is tested in 2025 O-level additional math paper. Okay, so okay, let me go back to my PowerPoint slides. Okay, So yeah, okay, you may want to copy down the question as well, okay, on a piece of paper. Okay, so okay, let me go into slideshow mode. Okay, so you may want to write down the question on a piece of paper similar to the tutorial question. Okay, the 4 tutorial question that I went through. Okay, and then next week when you're in the center, I'll give you the physical handout. Okay, then you can do lah. Oh. Okay, so this question actually I copy from the exam paper the question. Okay, so solve the following equation Okay, 2 cosecant square theta minus cotangent theta minus figure 0, right? So like what I mentioned in the tutorial. Okay, so you can see in the tutorial question, most of the questions are straightforward, meaning you don't need to use any form of trigonometric identity, okay, to manipulate the expression. Okay, but for exam question like O level or even preliminary exam question, okay, sometimes or most of the time the student may require to use some form of trigonometric identity to simplify the trigon expression before even you can find things like your reference angle, deduce which quadrant the underlying angle lie in, and hence proceed to find the actual angle in that respective quadrant. Okay, you need to use some form of identity. So in this case, if you notice, we have a cosecant function here and a cotangent function here, correct? So what can you think of? Pythagorean identity, correct? Pythagorean identity, because from your formula sheet, okay, formula sheet this one okay, let me go scroll to the formula sheet page. Okay, from your formula sheet, this one okay, the first 3 are your Pythagorean identity. Actually, okay, like what I tell my students, okay, you remember sine squared a plus cosine squared a equals to 1, enough. The other 2 no need to memorize. The other 2 can be obtained by dividing sine squared a on both sides and cosine squared a on both sides respectively. You'll get the other 2. Okay, so the first 3 are your Pythagorean identities. Okay, why they are called Pythagorean? Because sine squared theta or sine squared a plus cosine squared a equals to 1 is derived from the right angle triangle using your Pythagoras theorem. That's why it's called Pythagorean identity. Okay, the next 3 is your compound angle identity, or like what some teachers call it, or like what your textbook define. Okay, they call it addition formula or sum or difference formula. For me, I'll call it compound angle identity. Okay, it's the same, they are equivalent. Okay, sum or difference or addition formula or compound angle formula or compound angle identity, they are all the same thing. Okay, it's just how different people call it. Okay, the last one usually is the challenging one, where a lot of 15 or 16-year-old boy or girl will face double angle identity. Because if you look at cosine 2a, your good friend here, you have 3 different expressions, and all 3 expressions are equivalent, and when to use them depending on the nature of the problem. Okay, depending on the nature of the problem. Okay, so the last part is usually the challenging one. Okay, double angle. Okay, so if you look at these 3 out of Pythagorean identity, compound angle identity, and double angle identity, okay, actually, okay, I can use Pythagorean identity, right, correct, to so-called manipulate cosine square theta into cotangent theta. Okay, because you see down here I have 2 different trigo function, correct, cotangent and cosecant. Okay, so I must change one of them either to cosecant theta or cotangent theta. Okay, in this case I will change the cosecant square theta to cotangent, because if you look at your trigonometric identity, cosecant square a equals to 1 plus cotangent square a. So if I do that, if I change my cosecant square theta to 1 plus cotangent square a, then my whole equation will be in terms of cotangent theta, which is easy to work with. Okay, then later you realize that you will get a quadratic equation. Okay, equivalent to quadratic equation. Okay, trigo equation is similar to quadratic equation. Okay, you just assume this is not cosecant, this is cotangent square theta. Then 2 cotangent square theta minus cotangent theta minus 3 equal to 0. What is that? It's like a quadratic equation, right? If you let x be cotangent theta, then you have 2x squared minus x minus 3 equals 0, correct? So trigo equation is similar to quadratic equation. Okay, so the first step here, I may want to use my trigonometric identity for Pythagorean identity. Okay, specifically cosecant squared theta equals to 1 plus cotangent squared theta. Okay, I may want to use this, okay, to manipulate cosecant squared theta, change to cotangent squared theta. So first thing, what I put here, recall sine squared theta plus cosine squared theta equals to 1. This is in the formula sheet, isn't it? The first one, correct? And if you divide both sides by sine squared theta, okay, so sine squared theta divide sine squared theta, that is 1. Cosine squared theta divided by sine squared theta, that is cotangent squared theta. 1 divided by sine squared theta, that is cosecant squared theta. Okay, which is what I just said. Okay, we are going to use this identity, okay, to substitute or to replace cosecant squared theta. Okay, so that the whole equation will be in terms of cotangent function. Okay, of course, the other Pythagorean identity, you divide both sides by cosine squared theta, you will get 1 plus tangent squared theta equals to secant squared theta, which is the second one. Okay, that's why just now I said for Pythagorean identity, no need to remember all three. You remember the first one will do. Sine squared theta plus cosine squared theta equals to 1. Okay, then you divide both sides by sine squared theta and cosine squared theta respectively, you get the other two Pythagorean identity. Okay, so don't need to memorize. Okay, for all three Pythagorean identity, just remember the first Pythagorean identity suffice. Okay, then compound angle, don't need to memorize. Formula sheet give you, memorize for what? Correct, the formula sheet is given to you there. You just need to know how to apply. That's it. Okay, so we are going to use this fact. We are going to transform the, or rather manipulate cosecant squared theta as 1 plus cotangent squared theta. Okay, then expand the 2 in, you have 2 plus cotangent squared theta. Correct, then minus cotangent theta minus 3. Okay, then what you do, I can further simplify the 2 and minus 3, I can group together, which is minus 1. Okay, like that. Okay, so 2 cotangent squared theta minus cotangent theta, then 2 minus 3 minus 1. Then what is this? Quadratic equation, isn't it? If you let x equals to cotangent theta, then this becomes 2x squared minus x minus 1 equals to 0, which is your quadratic equation in E-math. Okay, which is, you can use the cross method approach to factorize out 2x squared minus x minus 1. Okay, or equivalently, 2 cotangent squared theta minus cotangent theta minus 1. You can use cross method. You factorize out, you get the product of 2 linear factors. And what are the linear factors? 2 cotangent theta plus 1 times cotangent theta minus 1 equal to 0. Isn't this your E-math? Correct? So I think I said this to both you and Shermin. Okay, trigonometric equation is like quadratic equation. Okay? So from 2 cotangent squared theta minus cotangent theta minus 1 equals 0, this is like your E-math. Correct? You factorize out, you get 2 cotangent theta plus 1 times cotangent theta minus 1 equals 0. Okay, then either 2 cotangent theta plus 1 equals 0 or cotangent theta minus 1 equals to 0. Alright? Then for the first part, cotangent theta equals to negative half or cotangent theta equals to 1. Okay? Now, before we use our ASTC rule, because our ASTC rule is for all the trigo function is positive in Q1, correct? For Q2 is only sine positive. For Q3 is only tangent positive. For Q4 is only cosine positive, correct? But cotangent, is it part of ASTC rule? Actually, yes. Cotangent is reciprocal of tangent, right? Which is Q4 and Q1. Okay, so the next step you may want to do is, okay, you may want to convert cotangent to tangent theta. Okay, so, and we know that cotangent theta can be expressed in two ways. First way, sine over cosine, correct? Or second way, 1 over tangent theta. So, we will use the second one, which is 1 over tangent theta. Okay, in order not to complicate things. Okay, so we write cotangent theta as 1 over tangent theta. Okay, then, okay, the next thing is, we want to make sure that our left hand side is tangent theta and not 1 over tangent theta. So what you do, you take reciprocal on both sides. Okay, so for 1 over tangent theta equals minus half, if I take reciprocal on both sides, meaning 1 over tangent theta, that is tangent theta. Okay, then on the right side, 1 divided by minus half, that is minus 2. Okay, then for the other side, 1 divide 1 over tangent theta, that is tangent theta. 1 divide 1, that is 1. Okay, reciprocal of itself is itself. Remember, reciprocal of itself is itself. 1 divided by 1 over 1, that is 1. Okay. Then this is like just now the tutorial exercise, right? Easy, okay. You get down a very simple expression. Tangent theta equals minus 2 or tangent theta equals to 1, right? Then the next step is find reference angle. Okay, once you are able to simplify from the given expression down to the last one, okay, the subsequent step, okay, are the usual steps, okay, that you should do as per the tutorial exercise. Find reference angle, deduce which quadrant the underlying angle lies in, hence proceed to find the actual angle where it lies in the respective quadrant. Okay, and then the last thing is to do sanity check lah. Okay, make sure your answer fall within the range 0 to 360 degree inclusive, as well as okay, it satisfy the equation. Okay, make sure you get 0 on the right hand side for all the values of theta that you found. Okay, so yeah, if you are able to do until the last step here, I will say that okay, the remaining step is easy. It's like the tutorial exercise. Find reference angle for tangent theta equals to minus 2 as well as tangent theta equals to 1. Okay, for tangent theta equals to 1, the reference angle is easy. Inverse tangent 1, which is 45 degree. Okay, notice here the inequality is degree. So you should leave your answer in degree. 45 degree, not pi over 4. Technically, pi over 4 is 45 degree, but the question gives in degree. So you need to make sure you leave in degree, not radian. Okay, jangan remember jangan. Okay, but for tangent theta equals to minus 2, okay, like I say, you see, this the first part, tangent theta is negative, right? Correct. So when you find alpha, okay, or reference angle or basic angle, okay, you drop the minus sign, this negative sign here, you drop. So it will be inverse tangent 2, positive 2. You take only strictly the positive value, okay, to find alpha. So you do that. Okay, for tangent theta equals minus 2, your alpha will be inverse tangent positive 2, which is 63.43 degrees. Okay, for the other one, 45 degrees, special angle. Okay, because you ask yourself, how I get inverse tangent 1? You ask yourself, tangent what give you 1? The answer is 45 degree, your special angle. Okay, clear? Then, once you have reference angle, the next thing is you proceed to find which underlying quadrant theta lie in for this part and this part. Okay, so for the reference angle 63.43 degrees, okay, since tangent theta equals to minus 2 is negative, this tells us that theta must lie in Q2 or Q4, because in the case of tangent theta positive, it is in Q1 and Q3, right? So negative is the other two quadrants, Q2 and Q4. Okay, here. Okay, since tangent theta equals to minus 2 is negative, this implies that theta belong to Q2 and theta belong to Q4. Okay, and then you go and find out, okay, theta 2 and theta 4. So for theta 2, it will be 180 minus 63.43 degrees. For Q4, it will be 360 degree minus 63.43 degree. Hey, what did I press? Jump to the last slide. Sorry. Again. Sorry, I think I pressed towards the last slide. I pressed the shortcut key. Okay, wait, let me go back again. Okay, first let me enable my laser pointer. Okay, so okay, here. Okay, then you find theta 2 is 180 minus 63.43. Okay, theta 4 is 360 minus 63.43. Okay, which is 296.57 or 296.6 degree, round up to 1 dp. Okay, and then theta 2 116.6 degree. Okay, for angle okay, need to lift to 1 dp because if you look at your exam paper, the instruction, okay, here, this part, give non-exact numerical answer correct to 3 SF or 1 decimal place in the case of angle in degree. Okay, so this one apply. If you don't round to 1 dp, marks will be penalized. So remember, okay, this is very important. Okay, for angle, okay, related, final answer always give to round 1 decimal place or 1 dp. Okay, for non-numerical answer that is not pertaining to angles, which means geometry, 3SF. Okay, standard O level rounding off. Okay, this part here, your cover page. Okay, if not, marks will be penalized. So you leave like that, marks will be penalized. It should be 116.6 degree and 296.6 degree. Okay, for tangent theta equals to minus 2. Okay, for tangent theta equals to 1, in fact, it's a positive 1. So tangent theta is positive. So it lie in, theta lie in Q1 and Q3. Okay, Here, since tangent theta equals to 1 is positive, this implies that theta lie in Q1 and theta lie in Q3. Okay, then you find for Q1, okay, theta equals to alpha, which is 45 degree. For Q3, theta equals to 180 degree plus 45 degree, which is 225 degree. Okay. Okay, so the final answer will be 45 degree, 116.6 degree, 225, 296.6 degree. Okay, so these are the final answer. Okay, that satisfy 2 over sine square theta minus 1 over tangent theta minus 3 equal to 0. Okay, as well as if you check all the 4 answers here, clearly they fall in the range of between 0 degrees to 360 degree inclusive. Okay, yeah, the sanity check I leave it to you to verify all 4 of them. You substitute into here, but take note this one you have to rewrite the function as 2 over sine squared theta minus 1 over tangent theta minus 3 equals 0, because your calculator don't have cotangent and cosecant function, correct? Your calculator only got sine, cosine, tangent. So this one, for this expression, if you want to do sanity check, you need to rewrite this expression as 2 over sine squared theta minus 1 over tangent theta minus 3 equals 0. Then you substitute each of these 4 answers. Make sure you get kosong, 0. Okay, clear? Okay, so yeah. So the first part, I just quickly reiterate the process again. First part is, look at the expression, ask yourself, do I need to use any form of trigo identity to simplify? Or I can use my usual rules of mathematics, like factorize, whatever. Okay? Okay, multiply both sides by the denominator. Okay? I call it usual rules of mathematics. Okay? Or do I need to use identity? Okay? Then after that, okay, you simplify. Once you simplify until it looks like a quadratic function, then okay, you should be able to get until tangent theta equals to minus 2 or tangent theta equals to 1. Okay, so from this step onwards is the usual things like what we have covered in the tutorial. Okay, find reference angle, deduce the underlying angle the quadrant lie in, and hence find the actual angle that it lie in. Okay, and then the last step is to validate your answer. Make sure is your answer satisfy the equation as well as it fall within the range given in the question. Okay, next one, okay, will be the proving question, right? Part A is the proving question followed by solving question. Okay, so for part A, question 9 paper 1. Okay, so this is 2025 O-level A-Math paper 1 question 9 part A. So on left hand side you have 1 plus sine 2 theta divided 1 plus sine 2 theta divided by sine theta minus 1 plus cosine 2 theta divided by cosine theta equals to cosecant theta, right? So at one glance, your thought process may be to make common denominator, correct? Multiply cosine theta to this fractional term or rational function, and then multiply sine theta over sine theta to this rational term, correct? But actually, make common denominator is the second step. The first step is you need to manipulate the given expression on the left hand side using some form of trigo identity. Okay, but before that, when you're asked to prove trigonometric identities, okay, normally we always start with the complicated side. Okay, because the side that is not complicated, nothing to do. Like for example, if you start with the right hand side, CSC theta, we know is 1 over sine theta. Correct? Then how to simplify 1 over sine theta to get the difference of two rational function? Correct? From 1 over sine theta, how you simplify to get the difference of two rational function? Not possible, right? So we will start with the left hand side. Okay, so in general, proving trigonometric expression always start with the complicated side. In this case, 2025 O-level A-Math paper 1 question 9 part A, we will start with the left hand side first. Okay, and if you observe the left hand side, okay, actually we have double angle identity sitting in the numerator. Okay, for this part and this part, correct? For this part, sine 2 theta. For this part, cosine 2 theta, correct? So we have double angle identity. And if you refer back to your formula sheet, okay, the last three part of your trigo identity, correct? You see that sine 2 theta or sine 2a is actually 2 sine theta cos theta, right? And then you look at our friend here, cosine 2 theta, right? Actually, this 1 plus cosine 2 theta is together. Because if you look at our cosine 2 theta, just now I said, right, you have three different expressions, and all three of them are identical, which to use depending on the nature of the question. So, okay, cosine 2 theta can be equals to cosine squared theta minus sine squared theta, or cosine 2 theta can be equals to 2 cosine squared theta minus 1, or cosine 2 theta can be equals to 1 minus 2 sine squared theta. Okay, so actually how you get 1 plus cosine 2 theta? Actually is the second one, this one. Okay, cosine 2 theta equals to 2 cosine squared theta minus 1, because if I move this minus 1 to this side, is the same as adding 1 to both sides, right? Correct? So 2 cosine squared A minus 1 plus 1. The minus 1 plus 1 kosong, right? 0 and then I move to here will become what? 1 plus cosine 2A, right? And what is 1 plus cosine 2A? Isn't this the same as this? Correct? So 1 plus cosine 2A is what? 2 cosine squared A, correct? Okay, so I put it here. Okay, recall cosine squared theta, cosine 2 theta equals to 2 cosine squared theta minus 1. Okay, which is the second one, this one. Okay, 2 cosine squared A minus 1 equals to cosine 2A. Okay, this part here. Then if you add 1 on both sides, okay, you get this, right? This part here. Correct? You add 1 on both sides, you get this part. So you have 1 plus cosine 2 theta on the left hand side, and then 2 cosine squared theta on the right hand side. Okay, and then you see that this part here, the second rational term, okay, the numerator 1 plus cosine 2 theta essentially is 2 cosine squared theta, correct? And then your denominator is what? Cosine theta, right? You have a degree of 1, correct? Which means you can cancel out one term in the numerator. Then your numerator will be left with 2 cosine theta over 1, which is 2 cosine theta. Then that is where you make common denominator. Okay, so once you have simplified using some form of trigonometric identity, you can make common denominator. Okay, express the difference of two rational term into one rational term. Okay, so I'll show here. Right, left hand side. Okay, so proving question, you always start from one side. Left hand side, so you copy the question. So this first part is from the question. I do nothing. I just copy down. Okay, then the one in red color is where you need to use some form of trigonometric identity to manipulate into this part. Okay, the other, okay, into 2 cosine squared theta. In this case, the trigonometric identity that I'm using here is double angle for cosine 2 theta. Okay, so you do that. 1 plus cos 2 theta is actually 2 cosine squared theta. Okay, okay, and then you realize that cosine squared theta over cosine theta, this is like your iMatter, right? Cosine square x divide cosine x, which is cosine x, or 2x square divide x, which is 2x, correct? If you let x be cosine theta, correct? So 2x square over x, that's 2x. Okay, okay, then you will see that this term only have 2 cosine theta, correct? Then subtract from 1 plus 2 sine 1 plus sine 2 theta over sine theta, correct? So basically you have 1 plus sine 2 theta over sine theta minus 2 cosine theta. Okay, then what you do? Make common denominator, okay, which is, okay, what you may initially thought of, make common denominator, but the make common denominator part will come in the second step. Okay, after you have used some form of trigo identity to manipulate the expression. Okay, in this case, I will only need to use double angle identity for cosine function to manipulate the 1 plus cosine 2 theta into 2 cosine squared theta. Okay, then after that, I multiply sine theta over sine theta to this part here. Then you see magic. Okay, of course, this cosine 2 theta, okay, maybe let me write, wait. Okay, this one and this one will cancel, right? Okay, so you have 2 cosine theta. Okay, okay, so you left with 2 cosine theta. Okay, then times sine theta over sine theta. So now, okay, both rational term has common denominator, that is sine theta. Okay, so our numerator will be 1 plus sine 2 theta minus 2 sine theta cos theta. Then if you look at 2 sine theta cos theta, what is it? Your double angle identity for sine, right? Sine function, correct? Which is sine 2 theta, correct? Then you change to sine 2 theta. Then you realize that this sine 2 theta will cancel out with this sine 2 theta, which is 0, correct? Essentially, you left with 1 over sine theta, okay? Which is cosecant theta. Then you make a comparison to the original question on the right hand side, correct? CSC theta, CSC theta. By the way, COSEC can shorthand as CSE. Okay, both means cosecant. Okay, and you make a comparison, clearly we get the right hand side. Then you just conclude equals to RHS. Shown. Finish. Like that, 4 mark. Okay. Part B. Hence. You see the word hence? Okay, let me underline. Hence. Okay. Hence, which means I don't need to do so much work. Okay. I can make use of my part 1. Okay, wait, I think it's lagging. Okay, I can make use of my part 1 answer. Okay, because from part A, we already proved left hand side equals to right hand side. So, and part B, they give you the left hand side. Correct? It's equals to 2 sine theta. Correct? And from part A, we know that the left hand side is actually cosecant theta. And cosecant theta is the reciprocal of sine theta. Correct? Which is CSE theta equals to 1 over sine theta. Okay, so we do that. Okay, by part A, 1 over sine theta, okay, which is cosecant theta, okay, which is we can also write as 1 over sine 2 theta, 1 over sine theta, okay, equals to 2 sine theta. Okay, then what you do? This is like your usual rules of mathematics, right? Okay, when you have a rational term on one side, usually we want to get rid of the denominator, so we get rid of the denominator by multiplying both sides by sine theta. Okay, so 1 over sine theta times sine theta, that is 1 on this side, and then 2 sine theta times sine theta, 2 sine square theta. Like A times A square lah, B times B square. So sine theta times sine theta, sine square theta. Okay, then okay, you divide both sides by 2, so that we from 2 sine square theta we make it to become sine theta, sine square theta. Okay, actually here I shortcut lah. Okay, there should be one more step in between, which is sine square theta equals to half 1 over 2. I divide both sides by 2. Okay, then finally the square, how to get rid, you bring over by taking square root. So sine theta equals to square root 1 over 2, and square root 1 over 2 is actually square root 1 over square root 2. Okay, using your property of surd, square root A over B is equals to square root A divided by square root B for positive integer A and B. Okay, because okay, square root is only defined for positive number. Okay, so square root half is actually square root 1 over square root 2, but square root 1 is 1. Okay, so that's why I have 1 over square root 2, and square root 2 is an irrational number. Okay, that's why the square root remain in the 2 there. Okay, but root 1 is 1. Okay, then when you are taking square root, right, basically you have plus and minus in front, plus or minus. Okay, which means your answer for sine theta, okay, where the actual angle theta lie in will be in all 4 quadrants, Q1, Q2, Q3, Q4. Okay, so yeah, okay, before that, okay, you find the reference angle lah. Okay, so your reference angle will be inverse sine 1 over root 2. Okay, inverse sine 1 over root 2, and this is your special angle because sine 45 is root 2 over 2 or 1 over root 2. Okay, which is pi over 4. In this case, see, the question is given to you in radian. Your bound here is defined in radian. So, of course, you can live in degree. But, like what I say, don't forget to multiply by pi over 180. Okay? Then you get pi over 4. Okay? Yeah, that's my reference angle. Okay? Then, sine theta equals to plus or minus 1 over root 2. Okay, you can see plus or minus, right? Because sine theta equals to positive 1 over root 2. Which means when sine is positive, which 2 quadrant it lie in? Quadrant 1, quadrant 2, right? Correct? Okay, when you see when sine is positive, it's my pen. Okay, so you see if I take the positive one, okay, when sine is positive, my theta lie in Q1, Q2, correct? Now when sine theta equals to minus 1 over root 2, let me use a different ink. Okay, maybe green color. Okay, so when sine is minus, correct, sine theta is negative, correct, then lie in the other 2 quadrant, Q3, Q4. Okay, that's why I see. So in general, when you have a plus minus, automatically, okay, your angle, your actual angle will lie in all 4 quadrants. 1, 2, 3, 4. Okay? Clear? Then reference angle we already found, pi over 4. Okay, then the next thing is to go and find the actual angle theta in all 4 quadrants. For Q1 or quadrant 1, it will be pi over 4. Q2, it will be pi minus pi over 4. Q3, it will be pi plus pi over 4, which is 5 pi over 4. Okay, for Q4, it will be 2 pi minus pi over 4, which is 7 pi over 4. Okay, here I write the degree out equivalently for in radian. Like 45 degree is pi over 4, 3 pi over 4 is 135 degree, 225 degree is 5 pi over 4, and 315 degree is 7 pi over 4. Why? Why I write out? Because you look at the question. Again, the question is defined for you this. Correct? Theta is bigger than pi, less than 3 pi over 2. Okay, or equivalently in radian, theta is bigger than 180, less than 270. Okay, and if you look at the 4 answers that you have found, 45 degree, 135, 225, 315. Correct? If you compare with the inequality here, okay, where they tell you theta should be bigger than 180, right? Correct? In degree, and less than 270. Okay, 3 pi over 2 is 270. Okay, so which means your answer for your final answer for theta must fall between these two range. And you look at 45. Clearly, 45 is outside of this range, correct? Because 45 is not bigger than 180. So this one cannot be the answer. Neither can it be quadrant 2, because 135 is also out of the range, out of this range here. Okay, 135 is not bigger than 180. So okay, 225, yes, because 225 is bigger than 180 but less than 270. So this one. And then the last one, 315 is bigger than 180, yes, but it's not bigger than 270, correct? So it fall outside of the range. So this one, so out. So what is the final answer? In this case, 5 pi over 4. Okay, for the range defined in the question. Okay, this is the range, right? Define the question. Okay, so for this range, I can only have one answer instead of 4 answers here. 45, 135, 225, and 315. Okay, I can only have one answer, which is 225 degree, which is 5 pi over 4, because it satisfies this inequality. Understand? Clear, Jiaen? Okay. The last step that you may want to do is sanity check. Okay, you plug 5 pi over 4 into the expression, or in degree. Okay, you plug 5 pi over 4 or 225 degree into this expression. 1 plus sine bracket 2, okay, 10 pi over 4. Okay, because 2 times 5 pi over 4 is 10 pi over 4. Divide by sine 5 pi over 4 minus 1 plus cosine 10 pi over 4 divide cosine 5 pi over 4. Then is that answer equivalent to 2 sine times 5 pi over 4? Okay, so this one exercise. Okay, I leave it to you to validate your answer. Okay, okay, when you sub in theta 5 pi over 4 into the left hand side, is the answer the same as 2 sine 5 pi over 4? Okay, exercise for you to validate. Okay, so I think with this, okay, I come to the end of my presentation for 1st November 2025. Okay, so next week, 8 November, okay, we will, instead of going on to proving trigonometric identity, maybe we will do other question pertaining solving trigonometry, because down here in the tutorial I only do 4 questions. Okay, I only do question 5, question 12, question 16, and question 2. 4 questions only. So next week, 8 November, okay, we will carry on with solving trigonometric equation. Okay, we will do the other problem. Okay, and then the last lesson for 2025 will be on 15 November. Okay, then after that, okay, I will see you again in December, if you would like to continue, okay, with me. If you find my teaching is okay, you understand things like that, okay, then okay, we will continue in 6 December. Let me check. Is it 6 December? Yeah, 6 December. Okay, so 15 November will be the last lesson for 2025. Then okay, we have 2 weeks break before, okay, the tuition resume on 6 December. Okay, provided that you want to continue with me okay. If not, okay, I will end here. Okay, I will upload the soft copy of the worksheet for you to practice, okay, as well as the solution together with the recording. Okay, if not, okay, bye bye. Okay, and see you next week, 8 November. Okay, 12:50 p.m. okay, at the center. Okay, bye bye.